that the vision of ISO is making life easier, safer, and better. In recent years, ISO has taken the UN Sustainable Development Goals as its main goal. The most common ones are industry, innovation, and infrastructure. From this picture, you can see that the ISO have published more than 14,000 international standards in the field of industry, innovation, and infrastructure. Totally, ISO for now has published more than 24,000 international standards and related documents, covering almost every industry from technology to food safety, agriculture, and healthcare. Outside of the electrical field, ISO has a greater impact on our daily lives more than IEC do. So I will take ISO as an example and provide a detailed introduction to this organization structure, and I will introduce the procedure of the ISO international development. ISO is a global network of national standards bodies. ISO's members are the foremost standards organization in their countries, and there is only one member per country. Each member represents ISO in his country, so it means individuals or companies cannot become the ISO member. So if you ask me, Mr. Yuan, are you a member of ISO or are you a member of IEC? No, of course, I'm not, because there is only one organization for each country that can become a member of ISO. Usually, this organization is one of your government's department who is in charge of standards. And this department will take part in the ISO activities on behalf of your country. ISO members are divided into three categories: full members, correspondent members, and subscribed members. And each member enjoys a different level of access and influence over the ISO system. The full members can participate in various ISO activities and have the right to vote. And correspondent members are usually national organizations that have not fully engaged in the standardization activities and do not have the right to vote. But they can participate as an observers in ISO conference and receive information of interest to them. The subscriber members come from countries that have not yet established their national standardization institution. They can keep up to the date with ISO's work, but they cannot participate in it, nor can they be observed in committees. They cannot sell or adopt ISO international standards nationally. ISO members can choose whether they want to be part of the particular technical committees. If you want to take part in the technical committee, you can become the P members. If you just want to observe what the TC is doing, then you can become the O members. O members can observe the standards that are being developed, offering document and advice. And the P members can participate in the development of the standards by voting on the standard at various stages. And the last one is the International Telecommunication Union, which is called ITU for short. ITU is one of the 15 specialized agencies of the United Nations, and it is in charge of the information and communication technology affairs. ITU is responsible for allocating and management global radio spectrums and satellite orbit resources, formulating the global telecommunication standards, providing telecommunication assistance to development countries, and promote the global telecommunication development. Because ITU has no direct relationship with our jobs, so it have no great connection with the power industry. So I don't think we have a lot of contact with ITU. And besides of the International Standards Organization, and there are some advanced regional standards. And this organization can develop and publish regional standards. Among them, the Institution of Electronic Engineers, which is called IEEE for short, should be the one we pay much attention to because it's related to our electrical field and it's also widely used and popular around the world. IEEE's headquarters is in New York. It's an international association of electric technology and information science engineers. And the world's largest non-profit professional technology society. The IEEE was formed by the emerge of the American Society of Electrical Engineers and the Society of Radio Engineers in 1963. It has more than 4 million members around the world. Most of them are the electric engineers, computer engineers, and computer scientists. And this chart tells us the governance structure of ISO. The General Assembly is an annual meeting and is similar to the company's shareholder meeting. It's attended by the ISO's principal officers and delegates nominated by the member bodies. It means every year your country will send some delegates to take part in the ISO General Assembly. And the ISO Council is the core governance body of ISO, and it reported to the General Assembly. The ISO Council governs the operations of ISO just as a board of directors governs the operations of a company. The ISO Council is chaired by the ISO President and comprises 20 ISO members and the chair of ISO's policy development committees. So the Council is the most important management department of ISO. The TMB, which is the Technical Management Board, report to the ISO Council, and the TMB is responsible for the overall management of the technical work. The TMB is comprised of a chair and 15 member bodies, and it decided on the establishment of technical committees and it can appoint their secretary and chairman of the TC. The President's committee is comprised of the principal officers. It can advise the Council on the implementation of its decisions. It also ensures that the effective communication and coordination between the ISO Council, the Technical Management Board, and the 4 Council Standing Committee. It means the President Committee just give advice to the Council. Okay, from this slide, we can see the governance structure of IEC. It's quite different from the structure of ISO. In the middle of the picture, you can see the Council Board, which is called CB for short. The Council Board is the highest decision-making body and is responsible for overseeing the work of IEC. And CB is also responsible for proposing and implementing the policies developed by the Council, approving the agenda and preparing documents for Council meetings, receiving and reviewing the reports from the Standardization Administration, the Conformity Assessment Bureau, and the Market Strategy Bureau. According to the needs, and a consulting body can be established, and the chairman of the members of consulting body can be established. There are 3 departments under the Council Board. They are the Marketing Strategy Board, the Standardization Management Board, and the Conformity Assessment Board. The Standardization Management Board, which is SMB, is responsible for managing the standardization work or IEC, including establishing and dispatching the IEC Technical Committee or Subcommittee, and improving their scope of work. Establish the chairman and secretary of the Technical Committee or Subcommittee. The SMB can also assign this standard work and supervise the progress of standard projects development and revision time. The SMB can approve and maintain the ISO guidelines, review the approved need and plans for the new technology work, and SMB can maintain relation with their international organization. The Marketing Strategy Board, MSB, is responsible for determining the technology development trend and market demands in the field of IEC activities. And MSB will report to the IEC Council. It can develop strategies to maximize the investment in major markets. It can establish priority area for IEC technology and conformity assessment work to promote IEC's response to innovative and rapidly developing market demands. The Conformity Assessment Board is responsible for setting the IEC's conformity assessment policy. The CAB can promote and maintain the relationship between IEC and other international organizations in conformity assessment matters. It can create, adjust, and dissolve a conformity assessment system. It can check and implement the conformity assessment activities. It can check and continuous relevance of IEC's conformity assessment activity, and etc. According to the ISO and IEC directives, the procedure or standards development in ISO is the same as the procedure in IEC. There are 6 stages of development required by ISO, from the first new work item proposal to the final publication. Development and international standard usually will take 3 years, nearly 3 years. The Technical Management Board of the ISO will cancel all work items which have been on the work program for more than 5 years. So you got to finish international standard development within 5 years. If you exceed this time, this project will be cancelled by ISO. The first stage is the proposal stage. When you decided to propose a new international standard, the first thing ISO should do is to confirm that the new international standard in this subject area is really needed. At this stage, you got to prepare a new item proposal, which is called MP for short. You got to prepare the MP to explain the importance and the necessity of this new project, as well as the foundation of the preliminary work. And then you submit this MP to the committee for vote. And at this stage, there are two things we got to keep in mind. The first one is that the work item proposal must be within the scope of an existing technical committee or a subcommittee. So when you prepare a new proposal, you got to look through the existing TC and SC. You got to find out which TC or SC is suitable for your new proposal. It will take some time. And if there is no existing TC or SC suitable for your new proposal, then you got to apply to establish a new TC or SC first. That will be another story, and it's much more complicated than development new standard. And the second thing I think you got to know is that there are two conditions for successful voting. Condition one is that the approval of the new proposal by a two-thirds majority of the P members of your TC voting. Absences are excluded when the votes are counted. The condition two is that there are 4 or 5 P members are willing to send their expert to participate in the development of the new standard, at least. When the number of the P members in your TC is no more than 16, then we got to make sure that there are at least 4 P members who are willing to send their experts to join your job. When the number of the P members in your TC or SC is more than 16, then we got to make sure that there are at least 5 members who are willing to send their experts to participate in the new job. If both of the above conditions are met, then the standard project, the new proposal is approved, and then the new project team for the new proposal will be established by your TC or your SC. The second stage is the preparatory stage. At this stage, the working group must finish the working draft of the new standard, conforming to the ISO directives. Usually, a working group is set up by the parent committee to prepare the working draft. The working group is made up of experts and convenient. During this stage, experts continue to look out for the issues and copyright, patents, and conformity assessment. When you finish your working draft, the working draft document can be circulated until the experts are satisfied. When they are sure they have developed the best solution they can, then the working draft can go to the next stage. And regarding the time limit for this stage, the parent company should define the deadline for the working draft. And the third stage is the committee stage. The committee stage is the principal stage, at which comments from all members are taken into consideration, with a view of reaching a consensus on the technical content. All members shall therefore carefully study the text or the committee draft and submitted all the comments at this stage. The Secretary shall prepare a compilation of the comments and arrange for the circulation to all P members and all members of the committee. And in the compilation of the comments, the Secretary shall indicate the action taken on each of the comments received. And the fourth stage is the inquiry stage. The draft international standard is submitted to the ISO's Central Secretary by the committee manager. It will be circled to all the ISO members, and they got 12 weeks to vote and comment on it. The DIS is approved if 2/3 of the P members of the committee are in favor, and not more than 1/4 of the total number of votes cast are negative. If the DIS is approved, then the project will go straight to the publication. However, the committee leadership can decide to include the approval stage if it is needed. And the fifth stage is the approval stage. This stage will be automatically skipped if the DIS has been approved at the fourth stage. However, if the DIS has been significantly revised following the comments at the DIS stage or has technical changes, then the committee must carry out this stage. If this stage is used, the final draft international standard is submitted to the ISO Central Secretary by the committee secretary. The FDIS is then circulated to all the ISO members for a 2-month vote to decide whether the standard is suitable for publication. The standard is approved if 2/3 of the P members of the committee are in favor and not more than 1/4 of the total members of votes cast are negative. And the sixth stage is the publication stage, and it's the last stage of the procedure of the standard development. It should be cheerful because all the job for the experts in this working group is done. At this stage, the manager can submit the final document for publication through an app or through an interface of the ISO website. And after FDIS, only the editorial corrections are made to the final text. It's published by the ISO Central Secretary as an international standard, and the community managers and project leaders got a 2-week sign-off period before the standard is published. So that's all for the procedure of the international standard development. It's a long-term job and it's complicated. But from the slides above, we can see that the most important thing in the procedure is voting. And the approval criteria of the voting at different stages is quite similar, which are 2/3 of the P members of the committee are in favor, and at the same time, not more than 1/4 of the total number of votes cast are negative. It usually takes you a lot of time to communicate and coordinate in order to have support from other countries. So sometimes it's not a simple technical issue. This involves national interest and national competition. Okay, that's all for the international standard. Let's move to the next part. And I'm going to walk you through the standardization of China and Chinese power industry. And in China, the National Standardization Administration Committee, which is called SAC for short, and is the government authority for Chinese standard. According to the Standardization Act of China, The standards in China are divided into five categories, which are national standards, industrial standards, local standards, group standards, and enterprises standards. National standards are divided into mandatory standards and recommended standards, while industry standards and local standards are recommended standards. Under the management of SAC, China has established a comprehensive standard system and a standard management system for Okay, let's go on. In the Chinese power industry, the Chinese Electricity Council is authorized by the government to take responsibility for guiding the power industry of the power enterprises in carrying out the power sanitization. And with the development of power industry in China, we developed a lot of power standards. For now, there are totally 3,578 electricity standards in China. Among them, 550 electricity standards are national standards, and 2,787 standards are industrial standards, and 239 belong to the local standards. And up now, there are 120 standardization community under the management of the China Electricity Council, including C2 undertaking by the State Grid, and 18 by CEC, and 11 by CSG. And in the fourth part of my presentation, I'm going to give you a brief introduction regarding the standardization of CSG. And firstly, I will introduce CSG shortly. The CSG, China Southern Power Grid Company, is an important state-owned backbone enterprise in China. It's connected with the Nanchang-Meigong region power grid, with a power supply area of 1 million square kilometers for a population of 272 million. Its business scope covered Guangdong, Guangxi, Yunnan, Guizhou, and Hainan province, with AAC and 11 DC transmission lines operation at the 500 kV or above. CSG has been listed in the Fortune Global 500 for 18 consecutive years, and we ranked the 89 in 2022. It has obtained a number of world-class achievements. Okay, this slide introduces the management of our technical standardization. Let's go to the next slide because the time is limited. And in 2021, CSG has approved to establish the community on power market standardization in the energy industry. The CEC Technical Committee on Electrical Micro Smart Sensor Standardization and the Committee on Occupational Health standardization, etc. So far, CSG has 12 technical standardization community, as shown in the table on the right. Therefore, CSG ranks first in the industry in terms of the number of standardization community in emerging fields. And by the end of 2022, CSG has presided over or participate in the development of 14 international standards. 9 of them are IEC standards and 5 of them are ISO standards. And 35 foreign standards, 460 national standards, 677 industry standards, and 181 group standards. In 2021, CSG led or participated in the publication of 5 international standards. Okay, the number I will not read more to faster. Now CSG has 3 IEC young professionals in total, ranking the first in the Chinese power industry. And our young professionals rank first in China and second in the world in the IEC Young Professional Project. As we mentioned, CSG focus on the regional standardization. CSG hopes to work with the enterprises in Asia region to jointly build a platform for the cooperation of power standards, promote the mutual understanding of standards of power industry, and jointly improve the ability and level of the regional power standardization. And currently, IEEE and SIGRET and other non-profit professional and technical societies have performed pioneering the demonstration for regional standardization work, and it inspires us in promoting the regional power standard cooperation in Asia region, such as the SIGRET. SIGRET has not only promoted the development of the exchange of engineering knowledge and information among the energies and technical experts from different countries, but also added values to the knowledge and information obtained. And these positive cases provides us with the foundation and operational experience for building the platform for the cooperation of power standards. And as for myself, my job is to promote the regional standards cooperation, and it's my responsibility to maintain the contact with all the friends and colleagues from the power companies in various countries, and to jointly carry out the standard cooperation methods. So if you have any issues about the standards and standardization, please feel free to contact me at any time. And in the next part, I would like to talk about the standard system of smart grid. And with the profound changes in the global energy structure and pattern, large-scale development and application of clean energy has become the mainstreams of world energy development.
Okay, wait a minute, we continue.
Okay, sorry for the interruption. Let's go to the last part of my presentation. The last part is about the standard system of grid connection of green energy. From the chart, you can see that the architecture of the standard system uh, uh, with two layers. The first layer is the general technical requirement. It includes four categories: general principles, terminology, general standards for environment protection and safety, general technical guidance. The second layer is the professional technical fields, based on the actual dispatching operation and functional division of CHG. The professional fields are mainly divided into 8 categories: dispatching, operation mode, power generation, protection, communication, automation, power monitoring system, and security protection, integration. And these systems include 831 standards. And among them, there are 205 national standards, 340 industrial standards, 134 group standards, and 36 enterprises standards. Overall, the current standards for new energy grid connection are mainly based on the national industry and group standards, and supplemented by the international and enterprises standards. And here are some features of the standard system. And the first one is that the standards adopted in the system are abundant, and CHG may use of the advantage of the abundant resources, resulting in the system adopting a large number of the different standards. The system includes national standards, industrial standards, group standards, enterprise standards, and international standards. And the second of the feature is that the system is suitable for all kinds of green energy. It can cover the onshore wind power, offshore wind power, centralized PV, and distributed power generation, microgrid, grid, energy storage, and other type of energy with a wide range of applications. And the third one is the professional technical fields. And for the first time, the standards have been classified according to the various professional fields, such as scheduling, operational mode, and power generation, protection, automation, etc., and for the green energy operation. And the fourth one of the feature is that information platform. This standard system is presented on the CHG Technical Center. Or the CHG Technical Center Information Platform, which provides the standard retrieval, online browsing and download, status checking, and other modules. And that's all for my presentation today. And thank you very much for your attention. And I hope that we can keep in touch. And I am looking forward to the cooperation and communication with you regarding the standardization issues. So if you have any questions, I would be happy to answer them now. Okay, that's it. Thank you.
那个共享一下。Okay. Thank you.
Thank you.
Mr. Yuan.
See you guys.
Okay. We have a last 5 minutes. 5 minutes. And then thank you. We continue and 5 minutes later. Okay. 好吧，时间到了。
刚才最后是什么？是个
刚才你那个
共享没想到是
没想到，对，共享没想到，没看到，
就没看到我的共享，这里有。
没事，因为发言人自己开。
啊，
这居然没看到
他，有问题可以在这个。
刚才怎么没共享呢？不会啊，这么奇怪。
前面也得有。
现在呢？
现在有啊，没关系。
行了，那我上去了。
辛苦了。
哎呀，准备太多了，不行，回去要删减一下。先念了一遍，才发现好多废话。
没事。啊，对。
每年这样搞一轮呢，要啊。
这应该搞一次。
去年就没搞，
去年疫情了。
前年也是在线上讲，做一下。
到那边。
好，行。
你要讲2个小时啊，你准备。
我后天还要再讲2小时。
天
，4个小时。
为什么不能缩短一点？
太忙了。对，回去还得凝练一下才行。
哦，对，开始投影。哎，好了。哎，不是，还在等待吗？
加入。
哦，是不是欧专家那边得通过一下？
你没加那个？
我刚加了一会儿。
加进来了吗？
没有啊，这个
没加。
我重新再加一次。哦，好的。你的扬声器。
他们加入。
哦，我知道了，扬声器已经
没有，你看了加入啊？
啊，我已经在这儿，这个是啥呀？这是
在这人，
对
你在这人，你共享一下。
我这讲话能听见吗？我看他提示我。哎，怎么共享屏幕？
那个，
哦，这，然后窗口是吧？哎，不对，应该是屏幕，这样的话就会方便切换。呃，但是我讲话就是能听到吗？就是怎么才能知道我讲话别人能不能听到？
这个是看你。
对，但是刚刚他提示什么？提示
你共享，你看到没有？
这个没共享是吗？哎，
共享没看到你，你在这里面吗？图中，
对，在这里吗？
你不是那个，你不是那个吧？
我在啊，这不是你吗？
没看，那没看到你，那个我看到你了，那没看到你共享的东西。
等一下啊，我这已经共享，停止共享，然后再共享一遍，包括这个对吧？
你 PPT，
现在是共享。
没有看到你是。对，看到现在共享这个，
这样能看见吗？这是我共享界面对吧？
你这个没有啊？
哦，可以开了。能听见吗？就是
哎，Hello，
Hello, can you hear me? 听见。
你这样，你看，你再说说。
Hello，啊，不对，不对，可能是我。
那直接你讲，我就不介绍啊。
你就开始了。
开始了。
Hello, good afternoon, ladies and gentlemen. My name is Tu, and I'm a researcher in CSG. I'm so glad to share the knowledge of power system simulation, calculation, and analysis with you guys. I am a member, a developing member of DSP Developing Group. It's my pleasure to introduce this software and its function. I will introduce three parts: power flow and transient simulation and short circuit calculation. So today in the next 2 hours, I will introduce the DSP first, then show the function of power flow calculation and the transient simulation function. Okay. 动了吗？哦，没动。等一下。哎，那应该怎么办？关机。就是这个，刚刚点的就是这个，后边就没了。PPT 呢？PPT 就这个。啊。喂。哎。也可以讲吧。Okay, doesn't matter. I can't open the full screen mode, but it doesn't matter. Let's continue. First, what is power system simulation? You know, DSP software, the full name of DSP is Digital Simulation Software, program or platform is both okay. What is the use of DSP? The main purpose of DSP is to simulate. So what is power system simulation? It means we build one fake system in our computer, but the external characteristics of the fake system is same as that of true system. That means we simulate the true system. Why we build the fake system? Give an example. If I want to know when tree branch fall on the transmission line and the short circuit fault occurs, how great is the short circuit current? Can the protection devices work normally? If I want to figure out this question, I can't do experiment on the real transmission line because I can't afford what might happen. Maybe the line is broken and it will cost a lot to repair. Maybe the death of person who do the test. So texting directly on the real power system is very dangerous, expensive, and difficult. So what I need to do is just open my computer, build the same system, give one short circuit fault on this system, and then the computer will give me the value of short circuit current. That's why the simulation is important to study, researching, and engineering. So we need this. Okay, except for the power system, in many career and field, they use simulation. Just like before the first time the pilot to fly a plane, you need to simulate how to fly. If you're a doctor, before the first time you do the surgery, maybe you need the simulation. Okay, that's the model of one power simulation, one power system. Power system dynamic simulation is a physical model system used to research dynamic characteristic of power system. So in conclusion, what's the advantage of power system simulation? No worry about the scale and the complexity of the system. No matter how big it is and how complex it is, I can build on a computer. The second is I don't need to worry about the security of system. No worry about the cost of the test because the device like transformer, transmission line, they are very expensive. We can't do the test directly on the real devices. we can predicting the future development of power system. If I want to build a new transmission line, to build a new power plant, I need to simulate first. Will it work normally? Then I start building. The next is DSP overview. Just brief introduce to the DSP software. Speak to that, I will show you the DSP pamphlet brochure. Wait a second. I changed the file. Okay. This is a pamphlet our DSP group made to introduce DSP, the digital simulation platform or digital simulation program. In DSP, it has three strong features applicable to high propulsion power electronic system, competitive with mainstream software such as PSSE and BPA. It means if you have BPA data or PSSE data, you can use this data directly on DSP software. You don't have to change the format of the data. You can directly run the program to calculate or simulate. The third feature is accuracy verified by long-term operation of power grid, because in the last 10 years, in the past 10 years, the DSP has been applied in so many engineering project. So the result of the calculation is very accurate. Then it's a short introduce to the DSP group. With the modeling and the simulation capabilities for DC transmission and power electronic converter, it is applicable to multi-scenario simulations such as AC grids, AC-DC hybrid grids, AC-DC grids containing large-scale renewable energy with maximum scale existing 1 million. No, it's 100,000 nodes, competitive with the mainstream commercial software such as PSSE, BPA, and adapts to different power system user, including three major modules: power system security analysis, power and energy balance analysis, and electricity market simulation analysis, meeting the simulation, calculation, and analysis demands in grid planning, construction, operation control, and real-time scheduling of modern power system. The calculation accuracy has been verified by comparison with a lot of real grid faults. It is becoming the best simulation platform in China South power grid, supporting the safe and stable operation of large AC-DC power grids. DSP has three major modules. Each module have so many little functions. In the in this lecture and the next lecture, I will just introduce the power the power flow calculation, short circuit current calculation, and electromagnetic transient simulation. No, it is electromechanical transient simulation. Just these three major and the most common part I will introduce. Let's have a brief overview of these three function. Power flow calculation function. The power flow calculation and analysis of AC/DC power grid, static stability analysis, data editing and viewing with graph model integration. The key feature of this function is multiple scenarios applicable to power flow analysis of modern power system, including AC/DC, renewable energy, facts, and so on. And the function has feature of fast convergency, PQ, Newton-Raphson, DCPF, and so many methods to support the fast convergency of large power grids, which is far faster than similar commercial softwares. Then is user-friendly operation, one-click batch calculation of power flow, automatic static stability analysis, and intelligent exhibition of calculation results. So it saves a lot of time. Strong compatibility, com compatibility, compatible with the power flow data and models in PSSE, BPA, avoiding repetitive modeling. You can use that data and model directly on the DSP. This is data editing and viewing picture. The second function is short circuit current calculation. Scanning short circuit current, including DC component in the all nodes of grid. Short circuit ratio calculation, considering the DC and renewable energy. Assessing excessive short circuit current risk in the power grid. The key feature is accurate calculation. Great applicability is suitable for short circuit current calculation in grid containing VSC converters, even for power grid excluding the generator, because the VSC converter will provide the short circuit current during the fault. Multiple setting choices, providing so many calculation conditions you can choose. Considering DC component, calculation of short circuit current, considering DC component supporting the evaluation of switching capability. You can use the result to evaluate if the switch can cut out, can work directly, can work normally. This is the picture of the function. The third function is electromagnetic transient simulation. The key features is rich model library, including synchronous generator, DC transmission, renewable energy generation, facts devices, loads, and the accuracy has been verified. Various fault simulation, auto generation, and accurate simulation of symmetric and asymmetric faults such as and reduce 1 and reduce 2, DC lockout, switch rejection, and so on. And any other little functions. Efficient parallel calculation based on multi-cores, multi-CPUs, multi-cloud platforms. Simulation speed increased by more than 300 times. Strong capability, the same. Okay. There are so many other functions in DSP software. Yeah. But in this lecture and in the last lecture, that is the day after tomorrow, I will introduce the first three function. Okay, let's back to the PowerPoint. The modern grid of China is large scale, high voltage, cross region, and the long distance. We face new challenges. We have so many DC system, high voltage DC, and FACTS devices, renewable energy. The traditional power system modeling and the simulation technology is not suitable for the modern power grid. The DSP developing group is built in 2012. In the past 10 years, more than 10 years, DSP has been applied in so many Chinese engineering projects. This is all the big and important project for the CSG company. Yeah, that is the functions I introduced in the pamphlet. It has so many little functions, and the power flow calculation, simulation, dynamic equivalence, short circuit current calculation. They are all important and useful. Also, we have many little functions under development, such as stability of small signal disturbance, medium and long-term hybrid simulation, relay protection calculation. The DSP software is upgrading in the future. In this page, it introduced the capability of DSP software. It can calculate 100,000 buses, more than 200,000 branches. The system with more than 200 two-terminal LCC HVDC system, 50 multiple terminal LCC HVDC system, 100 multi-terminal VSC HVDC system. The DSP version, in this lecture, we release the DSP international version. It's a special version and an English version for this lecture only, and you can run the program on Windows XP, Windows 7, and the Win 10 to it means the operating system, and the running environment is Net Framework 4.0 or later. And by the way, this version is special. It's just for the lecture, so we don't need the internet for the first time running, and don't need the hardware dongle. Just open the folder and click the CSG Studio dot executive file, and you can run the DSP program. It is how the DSP look like. And wait, I open the DSP software. Oh, 这就有点麻烦。Wait，
那可以没事。
哦，可以看到吗？
等下等一下，应该是，只要你在那红框里面就可以。
没有，因为我刚刚只是分享了那个界面。我等一下。Sorry, please wait. I share the screen again. Okay, this is the DSP software, and I opened the sample of IEEE 39 the little system, and the most useful and the most common little functions of this interface is search, Control plus F, and you can find the text you want to search. For example, I want to find the bus 26, and I click Control and F. Find next, and it will jump to the line containing this contact. And I can find all, and on this box, it will show you all the lines containing bus 26, and you can click to jump to the line directly. The second useful little function is comment. For example, if I want to make this line useful, but I don't want to delete the line, I click the mouse and select comment. You can see there is a dot plus in front of the line, and you can type in the dot the same, make this line useful. The program won't read this line. Jump to the next line directly. Common and uncommon. And the other functions I will introduce later. Let's get back to the PowerPoint. Okay, this is all the little functions of DSP. And I give you two samples. One is the IEEE 39 little system containing one DC system, two DC system, one DC transmission line. And the other is New Energy. It is based on the IEEE 39 little system, but I put the solar energy, and the wind turbine and system in this little system. The three, this three file is very important. First is DAT file. It contains the it introduce the topology of the whole system, containing the line, the nodes, the load, and the transmission. It means you have the DAT file. You can know the topology of the whole system. You can draw the whole picture of the system. And SWI file, it shows the parameters of all devices. It is just the transmission model parameters, containing all the transmission model parameters of the devices. XDG file, it is graphical. It is graph of the whole system. I can open for the example. Hold on. Wait. Wait. 哎，这样可以了。Oh, okay. This is XDG file. You can see. Zooming in. You can see this is the whole graph, whole picture of the system. It is easy to check and see the state and the parameters of each node and on the line. Later, I will do the power flow calculation and you will see the function of this graph. In the DAT file, you can see it contains the B card, means the node card, and it contains the active and reactive power and loads of this node. The B means node, and BQ, BS, they all means node, but they are different types of node. You can also call this, they are all buses, the same. The T card means the transformer, and the L card means the line. T card means transformer, and LD card means the transmission line. DC transmission line is a different from the AC line. So there's another card called LD. Yeah. So you can see in the data in the DAT file, they all describe the topology of the system. You have the DAT file and you can draw the picture. You will know which bus, which node connect to which node, and you can draw the whole system, but you don't know the parameters of each node and each devices. So you need the SWI file. In the SWI file, for example, this part is generator, the parameters of whole generators. This whole part is the detailed parameters of DC system. So you know the SWI file, and you will know the parameters of all devices. So both file, DAT file, and SWI file, you need them all to know everything about the system. Let's get back to the PowerPoint. Oh, 可以. Okay, it is working. Next, I will introduce power flow calculation. So what is power flow calculation? The power flow calculation is means the structure and parameters of power network are known, and the active power and reactive power absorbed or generated by each load node and source node are known. The voltage, amplitude, and active power of a voltage control node are given, and the voltage, amplitude, and the phase angle of a balanced node are given. The voltage, amplitude, and the phase angle of each node in the whole network are calculated, and the power distribution and network loss of each branch are calculated. The basic equation for solving power flow calculation is the node power balance equation. Uh, that is the definition of power flow calculation. So what it means? Just it means just if you know the power and the voltage of every generator, and you know the parameters of uh, of the devices like the transformer and the transmission line. You know the resistance and reluctance. You can calculate how great the current flow through this line. What is the voltage of on this node? Everything you can calculate. That means power flow calculation. And you can calculate the distribution and power loss in the network. So PF calculation is used for performance analysis, fault analysis, stability calculation, power system planning. For each bus in the power system, there are 4 variables to determine its operating state. Every node, every bus in the system, it contains 4 parameters. They are P, Q, U, theta. P means active injection, active power. Q means reactive power. Voltage amplitude. U means voltage amplitude. The theta means voltage angle, the phase angle. So for every node, generally 2 of the 4 parameters are known, while other 2 are unknown. So the bus can be divided into 3 types. PQ bus, you can also call PQ node, PV bus, and the V theta bus. PQ bus means I know the P and Q of this bus, but the U theta are unknown. PV bus means for the PQ bus, it's always the the plant bus generating the power plant. The it is belongs to this node. This kind of node counts for the majority of the power system. PV 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 bus. Oh, sorry. PV bus means I know the active power. and the voltage amplitude. But in this bus, the reactive power and the voltage angle are unknown. It is called a PV bus. It includes some power plant with the reactive power storage and the substation bus with the reactive power source. They are belong to this node. So the all nodes in the system, they are divided into three types. V theta bus, also called select bus, balance bus, buffer bus. For the power flow calculation, only one balance bus, balance bus is set, and the power of the whole network is balanced by the slack bus. The voltage amplitude and the voltage phase angle are known. The U and the theta are known. Always we give the U is 1 and the theta is 1 for the V theta bus. And then we can calculate. We have n bus and two n power flow equations and 4n variables. And we can write the power flow equations. So we can see the equation is non-linear. We cannot solve these equations easily. And what's more, it means this equation has multiple solutions, maybe not one solution. The above formulas are the most basic equations for power flow calculation. It is the basic knowledge if we study electro engineering in the college, we will know they are the most basic knowledge for the engineering. Because the equations are nonlinear, they must be solved by numerical method. For them, it is a mathematic problem. So the Newton-Raphson method is the best method to solve nonlinear equations in mathematics. Next is a brief introduce to the Newton-Raphson method. For the equations, we don't know the value of x. We don't know the solution. We give the initial value of the x. It means we can give it randomly. And we expand the equation into a Taylor series. And we can solve this Taylor series to get the x. Therefore, it is called the irritation. You can see it means I give the value of x and it calculate a result. And then I will compare if the equation is converge. If it is not converge, I will calculate again. It means I will put the x to the equation again to calculate until the equation converges. It is a mathematical method. The advantage of Newton-Raphson method, the fast convergence speed if the initial value is selected well. It can't be you can choose a, initial value, but you cannot choose very randomly. At least it will not too far away from the final solution, the final value. Generally 5 to 4 to 5 times of iterations can converge to a very accurate solution. It means the progress, the iteration progress, we just do 4 to 5 times and it will be over. The number of iterations is basically irrelevant to the grid scale. It means no matter how big it is, 4 to 5 iterations is very common. The second, the advantage is excellent conversion reliability. For the ill conditioned system, Newton-Raphson method can converge also. Newton-Raphson method is a math method for the the power system, because the R is far smaller than X, means in the system the resistance is far smaller than reactance. So the change of P mainly depends on the change of voltage angle, while the change of Q mainly depends on the change of the voltage. So we can give some simplification, and the equation can be simplified as this. No matter what the PQ method, it can also solve the equations. Although the PQ method requires more iterations than Newton-Raphson method, the amount of calculation for each iteration is much smaller because we give so many simplification, and this simplification has reason. It is depends on the characteristic of power system, the power grid. Therefore, the calculation speed of the PQ method is higher than that of NR method. At present, the PQ decomposition method is not only widely used in offline calculations such as planning and design, but also has been widely used in online calculations such as safety analysis. It is current fastest calculation speed of AC power flow method. In this picture, the x-axis means number of irritations. How many times, how many irritations are used to solve this equation. And the y-axis means power deviation. The smaller it is, it means it is closer to the final value. You can see this straight curve means
will equip automatically. We have a 10 minutes rest.
the nurses were very good looking. Did you see Ryan? I felt like it was in Grey's Anatomy.
After waking up from anesthesia, Kelly couldn't help telling her husband
ladies and
Brandon about
gentlemen.
all the
Let's
attractive nurses she
come
saw.
back.
I haven't been
And
attracted to
if you
anyone
have any
besides
question,
you.
So you're
you
attracted.
can chat in the group, in the Teams group. You can send message to me or to the group, both okay. If I or my colleague notice your message, we will reply to you. Thank you. You can see this line is PQ method. This curve is NR method, Newton-Raphson method. We can see in the first the PQ method irritate faster at first, then the NR method irritate faster. So in the DSP, we use the mixed method. We use both PQ and NR method. The convergence condition of PQ method is set relatively loose, then start by PQ method. If the calculation converges, save the result and go to step 3. If the calculation does not converge, go to step 2. In step 2, we search the minimum deviation in the iteration steps. Save the power flow result of step in this step and go to step 3. In step 3, we're taking the result as a new initial point and carry out Newton-Raphson power flow calculation. If the power flow calculation converge after calculation in step 3, the calculation is finished. If not, just go back until we get the final result. So you can see the red curve in the DSP. We use the PQ method at first, then use NR method, because the PQ method irritate faster at first, then the NR method is much faster. In the DSP, we can calculate the power flow in the grid, including both AC and DC system. The traditional method to solve this system is joint solution method. The joint solution method combines the AC power flow equations and DC power flow equations to solve the whole system. It can easily converge, but it needs more memory and take a long time. In DSP, we use the alternate solution method. We separate the system into two parts, AC parts and DC parts. Two parts have connections, interface. It is flexible, but it has bad convergency. DSP power flow calculation functions can also do N-1 principle. N-1 means the power system should be able to maintain stable operation after any device is disconnected due to a fault and the power supply still mismount. Other devices are not overloaded. The voltage and frequency are within in the allowable range. It means any part is cut off, is disconnected to the system. The whole system can still run normally and stably. DSP power flow calculation module also provides an auto N-1 scan function, which can easily and quickly complete this mission. Just like I introduced before, the DSP power flow calculation need only the DAT file. The SWI file is not needed in power flow calculation. SWI file is needed in the transmission, in the simulation, transient simulation part. And after you give the DAT file, and you will get the result file, PF file. And in the DAT file, you can see a lot of data. Almost conclude the bus data, aerial control data, branch data, data modification data. And in the bus data, you can see the BS card, B card, BQ card, B card, BD, BZ, they are all bus card. They are all bus data. But it represents different kind of bus. BS means V theta bus, B means PQ bus. PQ bus means the active and reactive power of this node, of this bus is known. The voltage, amplitude, and the phase angle are unknown. The BQ card, B card, they are all PV card. The branch data contains L card, T card, E card. They are all the line card and transmission card. LD, LZ means DZ, direct current line, transmission line card. And the aerial control card, AC card. It contains area name, select bus name, and voltage level contains the zone names. Okay. Let's open the DSP software, and you open the DAT file. It's okay. You don't need to open the SWI and XTG. You only just DAT file. In the file, you can see the AC card. The first few letters means what types of this card. This called AC card. This called I card. This called BD card, T card, R card, TR, LD card, BD card. And you can click the view, and this is a property. You will see the all parameters you should fill. For example, click the T card. In the T card, you can see this part is all the parameters you should write. The transformer, two terminal of the transformer means the bus name 1, bus name 2, and the bus voltage 1, 2, and the resistance, reactance, fixed tab of node 1, node 2. If you used the piece card or any other simulation software, you will familiar with these parameters. For example, the line, they are very common. In the line card, you click on this, and you can say the resistance, reactance of the line, and any other line to ground susceptibility and conductivity. The all parameters you should fill. You should fill. So what is the advantage of this type of showing? Because if I want to create a new card. For example, if I want to create a new bus, for example, bus 99, I just, at first I need to create a new node, a new bus, and I type a B and a space, and you can see the property just jump out. And you fill the parameters in this box. You don't have to write on this because it will be chaos and it's easy to make fault. And you use this box, it will be very convenient. For example, I want to create a bus 99 and the voltage is 100 and just ignore the other parameters and the bus 99 is created. And if I want to create a line, I just type in an L and a space, and this is a line card. You can write the parameters. For example, the bus 99 I create, and it connect to the bus 1. And the other, you can write the resistance, reactance on this to fill the parameters it need. This is how to create a system. After you make sure the system is complete and the parameters is right, you can do the power flow calculation. You just need to click the PF button, and the power flow result of the calculation will show. It gives a lot of informations. For example, this is the active load and reactive load of every bus from bus 1 to 39. This is the progress of invitations. It will show you the first time, the second time. You can see it takes almost 8 irritations to converge. This part is the voltage of every bus. It is the voltage, but it's a per unit value. It is the voltage, kilovoltage, and this is a voltage angle. You can see the voltage of every bus, and this is a power output by the generator, because you can see the 30 to 39, except for the 31. Okay, the 30 to 39, they all represent the generator. You can see the output, the power output, and you can also see the power flow through each branch. For example, the bus 1 to bus 2, it means the line. You create a line, bus 1 connected to bus 2. You can see the active power, reactive power flow through this line. And this is some information about the DC system. It contains a lot of Chinese characters. It's because the time is so tight and we don't have enough time to translate all the character into English. But you can use a translator to understand this first. Yeah, you can see it has so much information. And do you remember the XDG file? We can open the XDG file. XDG. Refresh. Open. Triple E.哎，为什么又绑定在一起呢？OK，喂 Okay, just ignore this function. In the XDG file, it should show the voltage of each bus and the power flow through every line and every branch. But there's something wrong. It can't show. Maybe it's the English version has some problem. We'll fix it later and upload a new version to the chatting room and the group. By the inclusion, we have the XDG card and we can easily to see the relationship between among every node and every bus, who connect to who, and what is the voltage of each bus, and the power flow, the current flowing through this each branch. You can see, so we have the better understanding of the whole system. That is the purpose and advantage of the XDG file. Okay, let's get back to the PowerPoint. Sometimes we have converge problem. Maybe there are so many reasons. The common reasons, maybe because the generator is not equal to load, or the parameters is not reasonable, or some other reasons. If you meet the convergency problem, if your data cannot converge, at last you should check the data and set the B bus. The two methods maybe will be helpful to you. This is the first part, power flow calculation. The next is transmission, a transient simulation. why we need the simulation. I introduce the purpose and advantage on the first lecture. In this part, I will show the transient simulation will will make sure we know if the power system is stable or not. What is power system stability? After power system suffer from disturbance, the reliability of each motor to keep the speed and transition to new steady state operating mode is called transient stability. It usually refers to the ability to keep in step during the first or second oscillation cycle. Serious disturbance generally refers to the short circuit fault, sudden change of large load or large capacity generator, removal of transmission or substation equipment, and so on. It is a simple example. If there is no disturbance, the ball may stay still at the balance point. But if you give a disturbance, it will leave the balance point. But in the E and G, it is stable because it will be still in the end. For the other point, it's not, because in the end it won't come back to the point again. Power system stability contains so many parts: rotor angle stability, frequency stability, voltage stability, and so on. In each kind of stability, there are so many little parts. What is stability look like? The three curve. Among the three curve, only the curve 2 is only the curve 1 means the black curve is stable, because the oscillation is great at the first, but as the time moves on, the curve become stable and oscillation is smaller and smaller. But for the case, the curve 3 and curve 2, the yellow and red curve, we can't see that potential. Okay. In China, we have a national standard called China's Power System Stability Guidelines. The necessary condition for normal operation of power system is that all generators keep synchronous. So we need the power system stability analysis to analyze the ability of each generator to maintain synchronize after large disturbance. This is a structure of a whole system, the model. It contains generator differential equation, algebraic equation. It is all the mathematical equations. Okay. This is a control system block diagram of LCC converter. You can see it's very complex. So the transmission, the model is very complex. So the transmission is the simulation is not very easy. In the DSP, we have a user-defined model. User can apply transfer function model in the DSP to build a new model, supporting the governor, exciter, PSS of generator, conventional DC system, flexible DC system. This is an example. We just build the generator governor, and this is corresponding scripts. It is how it saves the strings, cards. It's not just save the pictures. In the DSP, we also support secondary development. We support conventional DC system, flexible DC system, wind power generation system, solar power, and SPC Stacom. It means we can use the models we give, and you can also create new models to solve the new problems. And you can set fault in the system. For example, the single phase short circuit, two phase, three phase, two phase ground, three phase disconnection, generator tripping, and or load shedding. We also support DSP EMTDC hybrid simulation. DSP is electromagnetic simulation, and the EMTDC is like PISCART. Both simulation can stick together, perform mechanical. Oh, sorry, I was wrong. DSP has the mechanical simulation, and EMTDC is like PISCART. It has electromagnetic simulation. Electromagnetic simulation, it is more accurate, but it consumes more time. It's slow, but mechanical simulation, it is not that accurate, not that precise, but it takes a little time. It saves a lot of time. So in the engineering analysis, because the system is too big and too great and complex, we always use mechanical simulation to analysis and simulate. But if we want to know know some part detail, we focus on the some part. For example, if we want to focus on the DC system, we can use electromagnetic simulation to simulate the DC part, and the other AC part we use the mechanical system simulation. So we can get both the accuracy and time saving. So there's a comparison between the two types of simulations. So in conclusion, the electromechanical transient simulation is a little coarse but efficient. So that's why the electromechanical simulation is the most basic foundation and the function in the DSP program. This is a diagram to show you how to do the hybrid simulation. If you have a DC system in a grid, you can say for the HVDC system, you can put it in the detailed in the magnetic simulation. For the AC part, you can put in the mechanical simulation, and they are both connected and exchange the simulation result step by step. So it will make sure the result is accurate, but it is also very fast to finish. It is just an example, the result of a case. Okay, let's open the DSP software. If you want to do the simulation, you should not only the DAT, but also the SWI file. Okay, in the SWI file, you can see these, like I said in the first lecture, um, it in this file, it contains all the parameters of devices. For example, the LS card means the fault card. You write a fault. If you want to set a fault in the system, you should write a LS card. Okay, we click the view and property, and it will show all the parameters of this card. You can see LS card. You input different number, and you will set different fault. For example, one is 3-phase short circuit fault. This card means, and this parameter means times of failure, means the what time does the failure begin and what time does the fault is set. And the unit is cycle. If the frequency of the whole system is 50, one cycle equals 20 millisecond. So the two lines means on the line bus 1 to bus 2, this is a line just like this line. I set a three-phase short circuit fault on the 10 cycles, and in the 15 cycles I cancel this fault. Means this fault disappear. This is what we simulate. LS card. And the MF card, this whole part means it's describe the parameters of generator. This whole part generator. This whole part generator. We can see because the parameters of generator is very complex and so many. So we have to use a lot of card to describe one generator. For example, the M card means the generator subtransient model. MF card means generator mechanical model. FV card means excitation system. And F plus, it is belongs to the FV. Also means the excitation system. SI card means PSS model. SI plus has same means with of the SI. GM means governor model. GM plus same. GA card means servo system. And TV means hydro turbine model. TV, TW, they are all hydro turbine. TA, TB, and TC card, they means the steam turbine model. They are different synchronized. They are all synchronized generators, but they are different types. TABC, TATBTC, they are steam turbine. But TVTW, they are hydro turbine. They use the waterfall energy. All the parameters you need, they are all from the manufacturers. We can't just type and fill all the blanks randomly. They are set by the manufacturer. And if you buy a new generator, and the manufacturer will give you the introduction or the guidelines, and it will contains all the parameters you need. If you used a piece card or any other BPA or any other simulation software before, and you must be familiar with these parameters because they have much more parameters than this, especially for piece card because it's a electromagnetic simulation software. So the model is more precise and more complex. The DM, the DZ, they are all DC system model. LB is a static load model. Load is divided into static load and rotating load. LB means static load. FF is a calculation control card. It contains some basic parameters of this system. For example, calculation step, and the unit is cycle, means the two calculation time, the time between two calculation. If you write a small number, and it will calculate more times in the certain time, during the certain time. If so, the result will be more accurate, but it will cost more time. If you write a big number of the calculation step, so then the result will be more coarse, but the time consuming is less. Calculation start time. If you don't write anything, it means 0. Calculation end time. And the system reference frequency. In China, the frequency of the power grid is always 50. Means each cycle equals to 20 milliseconds. And there are some other parameters. Some of them is not mandatory. Means you don't have to fill, but some basic parameters you should fill. System, the program will give you write nothing. Next, 90 means over. And next is the output card, means what curves you want to see after we do the simulation. I need to see the result. What result you want to see? What curve you want to see? You should write on this. B means the node, the bus. Yeah, I want to see the curve of all the bus, and this is you can choose what the parameters of this bus you want to see. For example, the voltage on the phase ABC, and this is generator I want to see. G card. In the G card, you can choose to see many curves of one generator. The L card means the line. You can see the curves of the line. D means the DC system. So this part means you want what curve what parameters you want to see. You just write in this part. Okay, let's set a fault. This system with all these parameters, I set this fault a three-phase short circuit fault on the bus 1, but on the line of bus 1 to 2. It begins in the 10 cycles. The fault will disappear in the 15 cycles. And during this simulation, at the end of the simulation, I want to say this. Okay, just click the TS button. It is because we here. Okay, it's over because we calculate time. We write 2000. It's a little bit too long, so it takes some time to finish this because the fault will disappear in the 15 cycles. So you don't need to write the 2000 cycles simulation time. So this is the result file. In the result file, you can see a lot of information, but they are all characters. It's not very easy to understand. So we use the tool CSG chart. Just open this. You can see all this. This is the place you write the parameters of any elements you want to see. In the result, it will show in this software, and you can search. For example, I want to see bus 1. Okay, it shows the bus 1 voltage amplitude. Okay, you can see, you can zoom. If you, you can zoom. You can see when the fault occurs, the voltage of bus 1 drops to 0. And after the fault disappears, it rises again, and then it recovers to the normal. You can see the angle. You can see so many results. For example, you can select what types of result you want to see. For example, I want to see the voltage amplitude, and you click here, and all the result. This is all about voltage. It contains all the voltage, amplitude, and the angle of each bus. For example, bus 2. Okay, same, almost the same. You can see here, when the fault disappear and the oscillation is smaller and smaller time by time, and then it's stable. We call this system is a stable system. If the oscillation is bigger and bigger time by time, and then it's just chaos, it's not a stable system. It's an ill system. It means the system is not strong enough to defend the fault or the disturbance. For example, the bus 3, almost the same, because the bus 1, 2, 3, they are near to each other. we can check. We can check. Open the XDG file. The fault happened in this line. For example, we can select a node far away from the fault position. For example, bus 35. Okay, we find bus 35. Oh, bus 35 is a generator. It is okay. It is generator. You can see after the fault appears, it is not dropped to 0 because it's far away from the fault position. It drops a little. Of course, it will drop a little because a three-phase short circuit fault occurs, and then oscillation is smaller and smaller. It's a stable system. If you want to see the current, for example, the current, and you can see the active power. For example, active power of the bus 39. Bus 39 is a generator. You can see this is active output active power. And also you can select the reactive power. Okay, reactive power. You can see when the fault occurs, it rises and then fall. Why it rises? Because the voltage is dropped very fast, and you need reactant power to support the voltage, to support it from dropping, to save this system, to make sure it is stable. So that is the purpose and the function of reactant power. It support the voltage level of the whole system. So it is always rise after the fault occurs. You can see, and you can see angle, and this is all the parameters you write on the SWI file. You can also compare two different curves. For example, I want to compare the okay. Let's cancel this. I want to compare the volt of 30 and the volt of 1. Oh, this is bus angle. Okay, you can compare the two different curve, because the fault occurs on the bus 1, so it drops to 0, but for the 30 it is far away, so it just dropped to a little. You can add a lot of. Okay, that's the main function of the Pence simulation function. That is all I want to share today. In the next lecture, the day after tomorrow, I will show how to model a new energy system and how to calculate short circuit current. Thank you for today. Do you have any question? Please feel free to ask. 会议结束。哦，你提醒我是因为会议快到1个小时是吧？
是。
哎呀，我以为你是想让我下课。哦，我没理解。哦，我想起来了，这个1个小时它就要断一次。
断一次。
所以说你再帮我控制这个时间。哎，还好。对，也讲完了。
对。看看还有没有。